So today we are going to start a new chapter, and chapter name is square and square root, and it's the chapter number 3 according to your context pages. So in the last class, I had given to memorize the number 1 to 20 square as well the cube, and I know each and every one of you memorized. We'll ask today because to continue this chapter, we need to memorize number 1 to 20 square anyhow, and that's in the last class I have given to you people as PDF file. Okay, so I will ask you later. Now let us discuss at first that what's the square and square roots actually is. Because our chapter heading is square and square roots, that's why you have to know what is actually square and square. For that, let us move to the next slide, and that's you can see square means what. Chapter name is square and square root. Square means what? If you multiply any number twice, two times. Suppose we are having a number 4. This 4, if you multiply 2 times, whatever you will get your answer, this answer is called the square of this number 4. Square means 2. Square of any number means to multiply this number 2 times. How many times? 2 times. Suppose I said, what's the square of 3? It means what? 3 you have to multiply 3 times. After multiplying, whatever you will get, it's your answer. Means square of 3 is 9. If I say, what's the square of 2? Then what we have to do is that we have to multiply this particular number, that is 2 times. Whatever I will get as answer, it will be my answer. So suppose somebody has asked the question, then what's the square of 5? What's the square of 5? What does it mean is that 5, if you multiply 2 times, what will be your answer? For that, let us multiply one more 5, and we know 5 times is 25. It means square of 5 is 25. That's the basic of the chapter, square and square root. Square means if you multiply a number 2 times, whatever you will get, it's called square. And square root means which, suppose 5, if I multiply 2 times, I am getting 25. At that time, I can say that the square of 5 is 25. And second topic is square root. Square root means there is which number which, if you multiply 2 times, you will get 25. That's nothing but 5. So we can consider square and square roots as reverse. Let me take one more example, and then we'll discuss through definitions. You will understand in a better way. Suppose you are having the number 3. So if I say what is the square of 3, it means what? 3 I have to multiply 2 times. So 3 times is 9. So square of 3 is 9. Now square root means what? There is which number which if I multiply 2 times, I will get 9. So obviously you can see it is 3, because 3 if I multiply 2 times, I will get 9. That's why square root of 9 is 3. So square of 3 we have to write like this, 3 square, and its answer is 9. Now if I say square root of 9, at that time I have to write like this, root symbol 9 equals to 3, because 3 if I multiply 2 times, I will get 9. That's the basic and the root level concept of the chapter number 3. Now let us discuss the same through the definitions, and everybody of you have to write the definitions in copy rightly. Wait, let me wrap the screen. So I will discuss the definitions. You try to understand, and then quickly you note it. At first, the name which we are having in the chapter is squares, and then we are having the square roots. What does square means? Already we discussed. Square means if you multiply any number 2 times, what answer you will get? It is called the square of this number. And square root means, suppose you are having 25. So there is which number if you multiply 2 times, you will get 25. It is nothing but 5. Root over 25 or the square root of 25 is 5. So in the slide at first, I had given the definition of squares. The number obtained when a number is multiplied by itself means if you multiply any number with itself means with its own. Suppose you are having the number 9. So if you multiply 9 with 9, whatever you will get, it is called the square of this number. It is the number raised to the power 2. Means if you are having any number square, suppose 5 square. So these how to write? There will be a 2 raised above this 5 like this. 5 to the power 2, 7 to the power 2. It's the way we have to represent 7 square. We have to read like this, that 7 square, and answer is 49, because 7 if you multiply 2 times, your answer will be 29. Sorry, 49. So every one of you write the definition at first, which you have seen here. What are the squares? Number obtained when a number is multiplied by itself. It is the number raised to the power 2. Square equals to 2 into 2. So write the definition. Those whose video mode is off, I don't want to remove you people. Be conscious about the matter. Make it on. Square means number obtained when a number is multiplied by itself. Means if you multiply any number with the number itself, whatever you will get, it is the square of this particular number. Now, whom I will ask question, you have to give the answer. And how to write this square? Square, suppose you are saying the square of 7. So this you have to write in this is 7 superscript 2. It means 7 I have to multiply 2 times. After multiplying, what you will get? You will get 49. So this 49 is called the square of 7. Okay, definition finished. Now I'll ask some questions. At first, let me know the answer of the question from Tahera. Tahera, are you present? Because your name is there, but your video mode is off. I don't know whether you are present or not. Adnan Shakir. Adnan Shakir, unmute yourself. Click on the microphone. On the extreme left side, microphone is there. Microphone. Adnan Shakir. What's the square of 6? What's the square of 6? Ehsanul Karim. Ehsanul Karim. What's the square of 9? What's the square of 9? Square means what? These 9 I'm saying. So 9 you have to multiply with 9. Whatever you will get, it is the square. Mabrur Ahmed.
81.
What's the square of 7?
81, sir.
Yeah, that's right. What's
Sir,
the square?
81.
Yes, 49. Because 7 you have to multiply with again 7. Qasim Ahmed. What's the square of 8? What's the square of 8? Qasim Ahmed. What's the square of 8?
4 to the square 2.
If somebody is saying square, at that time this number you multiply with the number itself. I am saying the square of 8. So you multiply 8 multiply 8. 8 times is 64. Okay, Javed Akhtar. Javed Akhtar. Javed Akhtar. What's the square of 12? What's the square of 12? No, being in your home, only you are eating. You are not studying. Hamida Khatun, what's the square of 13? Who is there? What's the square of 94? Within 3 seconds. What's the square of 13? What's the square of 14? What's the square of 17? It means you not memorized. Huh? Have you memorized the answers? I had given on. Nura Begum. 7 square.
49,
Yeah. 8 square.
64,
12 square.
144,
Yeah. 15 square. Okay. Okay, now I think you understood what the square means. Square means same number you multiply only 2 times. And if it is cube, multiply 3 times. Finish. And square root means if you are having any number, suppose 36. Now, there is which number, if you multiply 2 times, you will get 36. It is called the square root. So, square root of 36 is 6 because 6, if you multiply 2 times, you will get uh, 36. Let me take one example on the whiteboard. Suppose we are having the number 81. Now, square root means what? Square root means there is which number which if you multiply 2 times you will get 81, and that's we know 9 because 9 times is 81. Now suppose square root of 25. So there is which number if you multiply 2 times you will get 25. Already we know 5, if I multiply with 5 how much you will get 25. So square root of 25 is 5. Now suppose you are having the number suppose 9. So there is which number if you multiply you will get 9. That's we know 3. Therefore, square root of 3, 9 is 3. Now, suppose we are having the number 100. Can anyone tell there is which number which if I multiply 2 times, I will get 100? Yes, that's 10. Because 10, if you multiply 2 times, you will get 100. Therefore, square root of 100 is 10. But the square of 10 is 100. Both are reverse. Okay. Let us move to the slide once again. Okay. Secondly, Secondly, you can see there are some special things we have to know if you want to continue the chapter. Second thing is if a natural number, if a natural number m can be expressed as n square, where n is also a natural number, then m is a square number. It means what? If you are having any number, suppose we are having the number 81. It is saying if a natural number m suppose 81 can be expressed at n square, means these 81 if I can write n square form means some any number square, suppose 9 square, at that time m is square root of this number. Suppose my m is 81 and this m I can write something square, suppose n square, n is my 9 and 9 square I write. At that time this 9 is called the square root of 81 and 81 is called the square of 9. Okay, it's not any important topic. Then also you write in the main topic. Second topic you write quickly, though it is not much important. Already I discussed. If a number m can be expressed at n square, if you are having any number, suppose 25, this 25, if you can write any other number square, at that time the this m is called a square number. Suppose you are having 36. This 36, can I write any number square? Yes, I can write 6 square. At that time, this 36 is called a perfect square number. Clear? If you are having any number, And this particular number, if you can write any other number square form, at that time this particular number is called a perfect square number. So write the topic in your main topic quickly. If you're writing finish, just raise the hand. Have to move to the next one. Okay. So second note was, if a natural number m can be expressed as n square, where n is also a natural number, then m is a square number. Okay, everyone, you do one thing. You take a screenshot of this page. Later on, you can write. Let me discuss what was the second rule saying. Second rule was saying that suppose we are having a number, suppose 81. 81. This 81, can I write any other number square form? Suppose we are having 81. This 81, can I write any other numbers square form? Yes, I can write, that is 9 square. So if I can write any other number square form, at that time this particular number is called a square number or perfect square number. Now suppose I have 18 instead of 81. Instead of 81, I have 18. This particular number, can I write any numbers whole square? No. At that time I cannot say this 18 is a perfect square number. Now suppose, let me take one more example. Suppose we are having a number, suppose 16. So 16, can I write any other number square form? Yes, I can write, that's 4 square. At that time I can say 16 is a perfect square number. Let me take the number, suppose 49. 49, can I write any other number square form? Yes, I can write, it is nothing but 7 square. So as I can write a single number square, that's why this 49 is also called a perfect square number. That was the basic of the second. Regarding square and square root, some special things are there which we have to know. And that, suppose root number 3, you can see all square numbers end with 0, 1, 4, 5, 6 or 9 at units place. Means if you are having a perfect square number, at that time its last digit will be either 0 or 1 or 4 or 5 or 6 or 9. It means it cannot end with 2, with 7 and with 8. So suppose let us consider a perfect square number, that is 36. You can see last digit is 6. Let us consider another number, suppose 49. You can see last digit is 9. Let us consider another number, 25. You can see last digit is 5. Let us consider one more number, suppose 100, perfect square number, last digit is 0. That's why the rule is saying that if you are having any perfect square number, its last digit will be either 0 or 1 or 4 or 5 or 6 or 9. But if it is ending with 2 or 7 or 8, at that time it can never be a perfect square number. Let us take one more example. Suppose we are having a number, suppose 22. So at last it is 2. At that time it can never be a perfect square number. Suppose let us consider one number, 87. Last it is 7. That's why it cannot be a perfect square number. Let us consider one more number, suppose 33. Last digit is 3, so it can never be a perfect square number. It means what? There is no special number which if you multiply 2 times you will get 33. Hope you understood. Next we are having square numbers can only have even number of zeros at the end. If you are having any perfect square number, suppose 100, At that time, lastly, only even number of zeros can be there, either 20 or 40 or 80. If there is 30 at that time, it can never be a perfect square number. If there is 40 at that time, it can be a perfect square number, though it's a mandatory. But if there are 5 zeros at last, it can never be a perfect square number. It means what? If you are having a number ending with zeros at that time, if the number of zeros is even, either 20 or 40 or 80 or 16 at that time it can be a perfect square number, otherwise no. But if you are having odd number of zeros, either 70 or 90, at that time it can never be a perfect square number. Keep the points in mind, because in the exercise, if you know these points by mouth, you can solve the exercise 3.1. Now, whom I'll ask, you have to give the answer. Ashik, you tell me, can this number be a perfect square number? Ashik, no, it cannot be a perfect square number, because how many zeros are there? 1, 2, 3, 4, 5, 6, 7 zeros are there. That's why this number cannot be a perfect square number. Okay. Now let us move to the what are perfect square or square number. And it is very important. It is the square of some natural number. If m equals to n square, then m is a perfect square number where m and n are natural numbers. For example, 1 into 1 equals to 1 square, 4 equals to 2 into 2, 2 square. Means, if you are having any number, suppose you are having the number 9. This number, if you can express in such a way that it is the product of same two number, at that time, this particular number, that is 9, is called a perfect square or square number. Question may can come like this. They will give some number. Suppose they given 16 and 17, and they said which one of the following is a perfect square number. You have to check that out of these, which one I can express as the product of same. Suppose 16. So you can write 16, 4 into 4. That's why 16 will be a perfect square number. Now suppose they given 18. 18 you cannot write as product of same two number. You can write 9 into 2, but they are not same. You can write 3 into 6. You can write 6 into 6. That's why these numbers could not be actually perfect square number. Okay. Now let us discuss the some properties of square numbers, and then we'll finish the class. First property. A number ending in 2, 3, 7 or 8 is never a perfect square. Example 15210286593, etc. Means, if you are having any number, suppose 77, if you see that last digit, only last one, either 2 or 3 or 7 or 8, any number out of these four, then this number couldn't be any perfect square number. Means, this particular number you cannot express as the product of same two number. 77 you can write 7 multiply 11, 11 multiply 7, but there is no special number which if you multiply same thing two times you will get 77. Similarly, suppose we are having the number, suppose 38. There is no such number which if I multiply two times I will get 38. That's why it is not a perfect square number. And that's how I can say, because last digit is was 8. That's why first rule is that if you are having any number which is ending either with 2 or 3 or 7 or 8, at that time this particular number couldn't be a perfect square number. Properties of square number, and property number 2. A number, a number ending 0, 1, 4, 5, 6 or 9 may not necessarily be a square number. Example 20, 31, 24. Earlier I said that if you are having any number which is ending with 0, 1, 4, 5, 6 or 9, at that time this particular number can be a perfect square number. But it is not mandatory. Suppose we are having the number 36. This number is ending with 6. and it is perfect square number. Now suppose if you are having the number 26, it is also ending with 6, but it is not mandatorily that if it is ending with 6, it will be or it should be perfect square number. It may be. That's why second rule is saying a number ending in 0, 1, 4, 5, 6 or 9 may not necessarily be a square number. Means if last it is either 0, 1, 4, 5, 6 or 9, at that time it can be a perfect square number or it cannot be also. Third rule, square of even number is even. If you are having an even number, suppose 4, so if you make this 4 square, whatever answer you will get, it will be also an even number. Suppose you are having the number 5, which is odd number. If you make its square, you will get how much? 25. So answer that is 25 also will be an odd number. Simply, even number if you multiply 2 times, answer will be even. Odd number if you multiply 2 times, your answer will be odd. Rule number 4, rule number 5, a number ending in an odd number of zeros cannot be a perfect square. Already I discussed. If you see that you are having any number which is ending odd number of zeros, either at last 1 0 or 3 0 or 5 0 or 7 0, means number of zeros is odd. At that time, this particular number could not be a or can never be a perfect square number. Rule number 6. The difference of square of two consecutive natural number is equal to their sum. Very important. Suppose you are having one number, suppose 4. 4. If you make 4 square, another number, suppose consecutive number, after 4, which comes 5. 5 square. And if you subtract these two, let me take one easy example, you will understand better. Rule number 6 is very important. The difference of squares of two consecutive number is equal to their sum. Suppose you are having a number 5, another number which should be consecutive, means serial wise, suppose 4, because they are consecutive. If you make their square, 5 square is how much? 25. 4 square is how much? 16. Now after making the square of any two consecutive number, if you subtract, answer will be what? Do you know? Sum of these two number, 5 plus 4 9, and you can check it once. 25 minus 16 is 9. One more example, let me take. Let us take one number, suppose 2, another number, suppose 1. They are consecutive because 1 2 both are serial wise. So if you make 2 square, how much you are getting? You are getting 4. If you make 1 square, how much you are getting? You are getting 1. Now subtract. 4 minus 1 is how much? 3. So rule is saying answer will be nothing but the sum of these two numbers, that is 2 and 1. 2 plus 1 is 3. One more example, let me take. Suppose we are having the number 6 and we are having the number 5. So we know 6 square is 36. 5 square is 25. If I subtract their square, how much I will get? I don't know. Simply 6 plus 5 will be how much? That much will be the answer 11. I know you understood. If you understood this particular question which I am writing on the screen, you write the answer of it on the chat box. Suppose you are having the number 7, you had made it square. Next number is 6, you had made it square. And then if you subtract, what will be your answer? Write it in the comment box. Similarly, if you are having the number, no. Answer will be sum of these two numbers. 7 plus 6 is how much? 13 is the answer. One more example, let me take. Suppose we are having the number 8 and 7. So if you make 8 square and 7 square, and then if you subtract, what will be the answer? Do you know? 8 plus 7, 15 is the answer. One more example. Suppose you are having the number 10, make it square, and you have the number 9, make it square. And then if you subtract, what will be the answer? 10 plus 9 is 19. It is the rule number 6. If you understood, yes, only Mabrur is giving the answers. If you understood the rule, then you tell me, everyone, what will be the answer of this particular number? 18 square minus 17 square. Within 1 minute, everyone write in the chat box. No need to solve. Simply what
35.
Mabru,
35.
you are writing 25. That's not. You have to add the numbers. Numbers are 18 and 17. How it can be? Yeah, 35 is the answer. Now you tell me what will be the answer of this number. If it is 118 and it is 117, what will be the answer? Quickly.
170.
Simply
230.
7 plus 8 is 20, 15, 5, remain 1. 1 plus 1 is 2 and 3, and 1 plus 1 is 233. Very, very easy. Okay, I know you understood. Time is going to over. Last one rule remain. Let us discuss this one. Last rule is saying a triplet m comma n comma p of three natural numbers m, n, and p is called Pythagorean triplet if m square plus n square equals to p square. It is very difficult actually, and that's very important as well. This rule is saying if you are having three number, any three number, suppose let me move to the next page. Suppose if you are having any three numbers, suppose you are having three numbers, suppose 3, 3, 4, 5. Now, if you make the square of this, 3 square is 9, 4 square is 16, 5 square is 25. Now, you can see one thing. If I add first two numbers, 16 plus 16 and 9, how much I am getting? I am getting 25, which is equal to this particular number. At that time, these three numbers are called Pythagoras or Pythagorean triplet. If you not understood, don't worry. Once again, let me take one more example. If you are having any three number, suppose we are having the number 2 and we are having 3. One is the example. Let me take suppose the number 3, 4, and 5. Three number I have taken. Then Pythagorean triplet is saying, that is rule number last one, that if you make the square of every number, suppose 3 square is 9, 4 square is 16, 5 square is 25. After making square, if you see that the sum of any two number is equal to the remaining one, at that time these numbers are called Pythagorean triplet. Triplet means three number, which is satisfying the Pythagoras theorem. That is hypotenuse square equals to base square plus uh, perpendicular square. That's regarding the geometry portion. Interestingly, here you can see 3 square is 9, 4 square is 16. If I add these 4, 9 and 16, how much I am getting? I am getting 25. And which number remain 5 square? It is also 25, means equal. At that time, these 3, 4, and 5 are called Pythagorean triplet. Triplet means three number, which is satisfying the Pythagoras theorem. Pythagoras theorem means, he said, if you are having any triangle, if you are having any triangle, at that time this hypotenuse square equals to this base square plus this perpendicular square. Okay, so if you understood the last rule, then each and every one of you write the example of a Pythagorean triplet, means such three number whose square of any two number is equal to the remaining number. If you understood, okay. And whatever I discussed, you will not understand better until unless you are practicing the slide which right now on the screen. That's why this screen, you take a screenshot of this page, chapter number 3, square and square roots, and each and everything whatever is there in the screen, you have to write in the main copy, and you have to memorize the definitions as well the properties of square number. In the last class, we'll start the exercise 3.1, and 3.1 fully you can solve without using the pen if you know the properties which I can given here, which I have given here, properties of the square number. That's why each one of you take a screenshot of it and write it in the main copy. Nice, you know how to write in the main copy and memorize this. We'll discuss these things in the next class, and we'll have some questions, and then we'll start the exercise 3.1. So your timing is already over, so you can leave now. Class 9 already done. So dear student of class, you can leave now. Yes, student of class 8, you are requested to leave the session. Dear student of class 9, those who already joined, it's very good. Be sure that your video mode is on. Until unless your video mode will be on, I will not start the session quickly. Javed Akhtar, Abdullah Chaudhry, Hifzur Rahman. Those name I'm mentioning, make your video mode on. Abul Hassan, Sajid, Nahian Ahmed. Already I have said that you have to write your proper name with your rule so that you can identify nicely. Talhauddin, Shakil Ahmed, Nahian, Abu Sufyan. Your video mode is off, make it on quickly. Okay, let me set up the session and then we'll start it. Okay, assalamu alaikum warahmatullahi wabarakatuh, everyone, those who already joined. In the last session, we had practiced the chapter number 2. Practice means some of the topics we had discussed. And today, I had prepared the slide of the revision chapter, which I had started in the last class. And we'll continue the exercise R1, that is revision chapter's first exercise. I think only question number 1 we had solved. The rest question we'll try to solve today. So let me share about you people once so that you are sitting properly with the proper materials. Hifjur Rahman, video mode on, Shakil on, Fatiha on, Abul Hassan on, Mehboob Ahmed. Abul Hassan, your name is written here properly. Dilshanur Rahman, Shamim Ahmed, Sami Akhtar, Nahian. Nahian, yes, you can leave the room if you don't want to attend the session nicely. Abdullah Chaudhry, Abu Sufyan. Somebody has written some improper names. So you change your name before I remove you. Okay. So dear soul, we are going to start the revision chapter. And the slide which we'll discuss is right now I'm going to share in the screen. Okay, so in the last class, during the school hour, we had started the revision chapter's first exercise. From there, we solved only the first question, which was to find the which was all about finding the value of some irrational numbers. That is, find the value of root 2 up to 2 decimal places. And then, as our school was closed, we couldn't proceed the exercise. Today, I thought that to finish at least up to the question number 2 to 6. So, if you cooperate, obviously we can finish it. Okay. So, if my sound is going rightly, everyone just raise your hand. You can see there is some symbols using this. You can raise your hand. Okay. Okay. So, question number 1 already finished. We'll start the session from the next question, that is from question number 2 of the exercise R1. Be sure that you are sitting in the copy book. So question number 2 is saying that write two irrational numbers whose sum and product are rational. Already in the school hour, I discussed what are rational numbers and what are irrational numbers. Rational number means the number which I can write in the form of p by q. And irrational number means these are called rational number. And irrational number means which I couldn't write in the form of p by q. These are called irrational number. So I know that you're having an idea about the rational number and irrational number. Regarding rational and irrational, some properties I had discussed. That's also I know you understood and try to remember it. On the basis of this thing, question number 2 is given, and question number is saying write two irrational numbers whose sum and product are rational. Means question is directing to write two irrational number. How many irrational number? Two irrational number. So that their sum and product should be rational. Means if I add these two numbers, suppose it is the first irrational number, it is the second irrational number. Irrational. Remember, irrational. Question is saying if I add these two irrational number, my answer should be a rational number. Again, they are saying if I multiply this particular two number, my answer should be also a rational number. So there are several examples you can give on the basis of the demand of the question. Let me give one example. You try to give some more examples, and you try to write in your main copy another example apart from this. Let me take one irrational number at first, and that's suppose 2 plus root 3. No doubt it is an irrational number. Question may can come, sir, how? Because 2 is a rational number. Already during the school hour I said if you are having one rational number and another irrational number, if you add these two, your whole answer will be irrational. That's why root 3 is irrational, 2 is rational, but I am adding, that's why this whole number will become irrational number. So I have considered one irrational number. They said we have to consider two irrational number. Let me do one thing. Instead of 2 plus root 3, let me take 4 plus root 3. You will understand better only. Let me take another irrational number 4 minus root 3. Also, I said if you are having one rational number and another irrational number, and if they are in subtraction form, then also their difference, whatever will be, it is also irrational. Here 4 is rational, but root is irrational, and I am subtracting. After subtracting, obviously some answer I will get. This answer will be also irrational number. At that time, this whole number I can consider as irrational. So question said write two irrational number. I had written it is the first irrational number 4 plus root 3. It is the second irrational number 4 minus root 3. And they said whose sum and product should be rational. Means these two number if I add, my answer should be rational. So let me add at first. Add means plus symbol. So let me give plus symbol I had given here. So you can see 4 plus root 3 plus 4 plus minus root 3. See, it is minus root 3, it is plus root 3. So if I cut, what remain here? Remain plus 4, here remain plus 4. 4 plus 4 is 8. And this 8 is a rational number. And remember, in question they said whose sum should be rational number. So you can consider this one as one example. I hope you understood. At first they said we have to consider two irrational number. I have considered the number 4 plus root 3 and 4 minus root 3. And then they say their sum should be rational. Sum means I have to add. So I added. So this plus remain here plus, this plus remain here, this plus and this minus became, we know, plus minus I written here. It is minus root 3, it is plus root 3, I carded, so remain plus 4 plus 4, we know 8, and 8 is a rational number, and they said answer should be rational already user. Now they said again we have to multiply, means again they said their product should be rational. So product means I have to multiply, so let me multiply, let me change the in. They said product should be also rational. So product means multiply. So let me multiply these two number which I had considered earlier. Multiply. See, if it is A, if it is B, if it is A, if it is B, then whom you have to give the answer? Everyone. Be prepared. A plus B. It is A plus B. It is A plus B. It is A minus B. So formula of A plus B into A minus B was what? Fatiha Sultana, quickly you tell. A plus B into A minus B. Formula was what?
A square minus B square.
Very good. Formula was A square minus B square. Wait, participants are till now joining. Ah, formula was A square minus B square. Third formula. Okay. So A square means A is my 4, so we have to write 4 square. Minus B square. B is my root 3, so I have to write root 3 square. We know already 4 square is 16. Let me write minus. Root 3 square root carted, so remain only 3. And 16 minus 3 is 13. And this 13 is rational. And they said, according to the main question, the answer should be rational. And after solving, I got my answer is rational. So you can give these examples as well. Now, tell me, have you understood? If you understood, just raise your hand. If you understood the example that we have to write two example whose sum means after adding answer should be rational and after subtracting my answer should be also rational. If you understood genuinely, then write one example in the chat box and in the main copy you write another example apart from the one which I have discussed and apart from the one which you are writing in the chat box. Okay, so write one example in the chat box quickly. I'll check it. You have to move to the next question. You are requested to unmute yourself. During the screen sharing, I couldn't move to the gallery. You unmute. Okay. So here I have given the two example as A plus root B and A minus root B. If you add this, you are getting 2A, which is rational. If you subtract, you are getting A square minus B, which is also rational. You can give some more example. Some of you can write 2 plus root 3 and 2 minus root 3. If you add, you will get 4. If you subtract, also you will get 1, which are rational. You can write the example of 3 plus root 2, 3 minus root 2. If you add, you will get 6. If you subtract you will get, sorry, if you multiply, you will get 9 minus 2 is 7. Yes. But question was saying two numbers, so you write two numbers. Okay, I hope you understood. Now let us move to the next question. And that's question number 3. Question number 3 is saying that write all integers between minus 5 and minus 6. It's very simple. It's a question of class 4. They are saying between minus 5 and plus 5, which numbers are there we have to write. So between minus 5 and minus plus 5, which numbers are there? Let us check it once. For checking this one, let us move to the discussion board. Let me draw a number line. Suppose it is a number line. If it is my 0, it will be plus 1, it will be plus 2, it will be plus 3, it will be plus 4, it will be plus 5. It will be minus 1, it will be minus 2, it will be minus 3, it will be minus 4, it will be minus 5. Now question said we have to write all the numbers between minus 5 and plus 5. So minus 5 is here. Let me change the ink. It is the minus 5, it is the plus 5. So between minus 5 and plus 5, which number? Number are minus 4, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, plus 4. So it's the answer of question number 3. Question was saying between minus 5 and plus 5, which numbers we are there? We have to write. And the numbers are according to the number line we got minus 4 to plus 4. Very easy question. So you write the answer in your main copy there between minus 4 and minus 5. The answers are Nahiam, I am removing you. Question number 3. Finish 4. 4 and 5 very important. Last year I had given in the main question, final exam. In the property, they given a property. In the property of indices already index. They given. Let me change the ink. In the property of indices, a to the power m divided a to the power n equals to a to the power m minus 1. Taking m equals to n, show that a to the power 0 equals to 1. It is the question number 4. Question is saying they given a to the power m divided by a to the power n, and this equals to a to the power m minus n. It is there given, and they said m and n we have to keep equal. After keeping equal in this equation, we have to prove that a to the power 0 equals to 1. So let us solve this one. You see the question once nicely. I have to move to the white book. Okay. In question they given g for given a to the power m divided by a to the power n equal to a to the power m minus 1. And remember, they given we have to prove m equal to n. At last I am writing. Now already in the property of indices, we know if base same and their division, then I can write the powers as subtraction form. Here base is a, here also a. So you write a. They are in division form. So first power was m and second power was n. So if division, we have to write in subtraction form. So you write m minus n. One the LHS already they are given, RHS m minus n. Now see m and both are equal. So instead of m, wait a moment.
Sir, your sound is not coming properly.
Yes, now I think sound is coming. Participants are joining. They are disturbing. You have to join at 11:15. Now you are joining and I am getting the disturbance. Okay. So they are given a to the power m. They are given a to the power m division. They are given a to the power m division a to the power n equals to a to the power m minus n. A to the power m division, this division I can write in this form. So m n equal to a to the power m minus n. A to the power m, in the below a to the power n they given. Now you can see they said m equal to n. So instead of this n, I can write m. On the RHS, I can write a to the power m minus n and m both are equal. So instead of this n, I can write n. So let me write. We know if we are having same thing in the above as well in the below. So answer will be 1. So a to the power m in the below a to the power n, if I cut, remain only 1 equals to. Here a m minus m. Same thing if you subtract, how much you will get? You will get 0. So a to the power 0. And remember,
Sir, how
that's
can
the
you?
say that's the say to prove, and already we proved that a to the power 0 equals to 1.
Sir, I not understanding once.
Not understood? Okay, once again I am discussing.
Sir, discuss one fast.
Yes. They given m and n both are equal, and they given a condition that a to the power m division a to the power n equal to a to the power m minus n. Using these, they said we have to prove a to the power 0 equals to 1. So let us prove. A to the power m division I can write in this form, a to the power n. If you are having a is to b, you can write a by b as well. Okay, equal to a to the power m minus n.
Sir, we can subtract m and n.
Yes, yes, listen. In the above a to the power m, let me write as it is. In the below a to the power n they given. So instead of n, I can write m because both are equal. So instead of n in the below, let me write m. On the
Sir, why,
RHS
sir?
they given a to the power m minus n. So instead of n, let me write m because both are same. Now see a to the power m in the above, a to the power m in the below. So if I cut, how much remain only 1 equals to. Here remain only a, here m, and both are actually subtraction form. So m minus m is 0. So a to the power 0. And remember, that's they said to prove that a to the power 0 equals to 1. That's I prove. You see it
Sir,
once again.
if we do by subtraction,
Huh?
m and n,
Yes, yes. Anyway, you will get the same answer.
sir, you show like this.
Like this, it's better. No more calculation. Simply see they what they did, a to their m is to them, this they given, and they said m and both are equal. So a to their m, this division I had written as in the below a to the power n. RHS remains same. A to the power m in the above remains same. A to the power n in the below. So I written a to the power, instead of this n I written m because n and m both are equal given. On the RHS, a to the power m remains same. After m it was minus n. So instead of this n I written m because both are equal. A to the power m in the above as well in the below. We know same thing in the above and below. We can cut after cutting how much will remain. It will remain only 1. So I written equal to m minus m is how much? 0. So I written 0. And remember, that's they said to prove that a to the power 0 equals to 1. That's after solving like that. I hope that you understood. If you understood, note it quickly within 1 minute. Everyone note it quickly without any question. And then if you are having any question, you can ask. Note it quickly. Quickly note it. Have you noted, everyone? Okay, let us start the question number 4, and it's of the same type. Now we solve the question number 4. And right now we are going to start the next question, that is question number 5. Question number 5, you can see in the property of indices, means regarding indices or index, they given a property that a to the power m divided a to the power n equals to a to the power m minus n, like earlier. And they said taking m equals to 0 means where you will see m, you put 0. And after putting, you show that a to the power minus n equals to 1 by a to the power n. Let me a bit zoom it. It's the question. In the property of indices, a to the power m is to a to the power n equals to a to the power m minus 1. Taking m equal to 0 means instead of these m, you write 0. And after putting, you prove that a to the power minus n equals to 1 by a to the power n. So let us start the question number 5. Very speedily we will solve it. Remember, they had given, if you are having book near you, you can see they given a to the power m divided by a to the power n equals to a to the power m minus n. Clear everyone? Yes. If division, this division I can write in this form by giving a slash. So I written a to the m divided by a to the n equals to a to the m minus n, same like this. Now also they said we have to prove, they given in the main question, you can see taking m equals to 0 means where there is m, we had to prove or we have to take its value 0 according to the main question. So my dear soul, it's the line we got from the first line. They given a to their m divided by a to their n, I written in this form, same RHS remains same. Now they said where m we have to prove 0, so putting m equals to 0, a to the power m, so it will become a to the power 0. In the below, a to the power n remains same. In the here a, in the above m minus n, so m's value if I put 0, I had put it, minus n remains same. Now see, just earlier we got a to the power 0 equals to 1 means if you are having any number power 0, its value is 1. That's why a to the power 0, its value I can write 1, I written. In the below, a to the power n, I written same. In the above remain a to the power 0 minus n. So 0 minus n is minus n, so I written here. And remember, that's they said to prove that a to the power minus n equals to 1 by a to the power n. And we got it after solving. Okay, once again I am discussing, you see once. In the main question, they given a to the power m division a to the power n equals to a to the power m minus n. This line I written in this form, a to the power m divided by a to the power n. RHS was a to the power m minus n, remain as it is. Now putting m equals to 0, in the main question they said m's value I have to put 0. That's why I put it m's value 0. Here also m's value I put it 0. A to the power 0 just we got will be 1, so I put it 1. In the below, a n remains same. In the above, on the RHS a, I written a, 0 minus n is minus n. And after solving, I got a to the power minus n equals to 1 by a to the power n. And remember, that's they given to proof, and after solving we got it. So I hope that you understood. Note it quickly, and then one question we give. we have to solve. Yeah. Yes, Abhulation.
Sir, a to the power 0 after equals to, there will be 1 or not?
After?
After equals to, a to the power 0 is there, but you have given a. At last, anything to the power 0, sir, is 1.
No. Here on minus n is there too. Here 0 minus n or not. If only it was a to the power there, that time we had to prove 1. But here they given a to the power 0 minus n. So 0 minus n. Now suppose 0 minus 7 is how much? Minus 7 or not. So 0
Yes,
minus n is also minus n. Understood or what, Abhulation?
yes, sir.
Because 0 minus 8 is minus 8. So 0 minus n is minus n. So every one of you note it quickly. Given a to the power m division a to the power n equals to a to the power m minus 1. Note it quickly. Everyone note it. I hope that you are finished. So we solved till now question number 2, 3, 4, 5. And according to my plan, we had to solve up to question number 6. So only one question remain, and but we are having the time only 8 minutes. So very quickly we are moving to the next question. That is the last question of the session. That is question number 6 of the exercise R1. So within 1 minute, everyone finish this question. Have to move to the next one. The last question of the session, that is question number 6, is saying I'm raving. Question number 6 is right now you can see on the screen, and it's saying that already I discussed in the last class. Question is saying find the LCM Find the LCM and HCF of the following pairs of numbers using prime factorization method. They are given some pair of numbers. Pair, two things make a pair. First one, suppose you can see 321 and 196. Two numbers they are given. So both the numbers together are called pair of numbers. So and they said we have to find the LCM and HCF of these number using prime factorization method. Prime factorization method, what already you know, we have to divide by the prime factor. So question number 1 already I have discussed during the class work. Question number 2 and 3 was homework. Now, as I discussed already, I don't want to repeat it again. You solve the question number 3 and I will observe before. Turn the video on again. Solve the question number 3 where we had to find the LCM and HCF of 408 and 170. Everyone quickly.
Sir,
Find the LCM and HCF of 408 and 170. 408 and 170. Quickly. Only 3 minutes remain.
Sir, I have not understood this question.
Already I discussed during the class hour. In the last Zoom session also I discussed. I had given as homework as well. You have to solve by prime factorization method. Means you divide only by the prime numbers or prime factors. Okay, let me take one example. Principal sir, kindly allow me to share the screen. Yes, Abdullah Chaudhry, solve it quickly. 408 and 170. During the class hour as well, during the last Zoom session I discussed. Sami Akhtar, Abida Khatun, Mr. Maksud, Nahian Ahmed, Murad Rabbani, Sajid Dilshanur Rahman. Yes, you can leave. Those whose name just I mentioned, you can leave the session. Samia, video mode off. Nahian, video mode off. You can leave the session, no matter. I don't want you people. Mr. Maksud, Tahmid. How can I know that you are attending the session? It can happen that only you joined and you went to the kitchen room. You started making the chana and motor. Sami Akhtar. Sami Akhtar. Huh? Why are you preparing the iftari? While you are attending the class, your video mode should be non-stop on. Okay, solve it and let me see the answer quickly. Nahian Ahmed. Murtaja Ahmed. Turn the video on. Solve question number 6-3 to find the LCM and HCF of 408 and 170. Abul Hassan, what's about the answer?
Sir, I have not got to.
Just you divide 408 and 170 by its prime factor. Can you divide it? Yes. After
Yes, sir.
dividing, which thing will be common in both the number? It's your HCF. And LCM means HCF multiply the rest every factors. Whatever will come, that's the LCM. Fatiha Sultana, what's about the answer?
Sir, HCF is 34 and LCM is 2040.
20?
40.
Yeah. Now Fatiha solve 160 and 320. It's HCF and LCM. Last question. Abdullah Chaudhry, what's about your answer? Abdullah Chaudhry.
Sir, HCF is 34 and LCM
Yes.
is 20.
Yeah, that's right. Yeah, it's the answer. Now we solve the same question. HCF and LCM of 160 and 320. Nahian Ahmed, what's about you? Nahian? I cannot see your face actually properly. Keep your mobile in
Sir,
a constant position. Yeah, now we solve it. Tasfiya Tahsin Wahida, what's about your answer? Till now solving, but time is going to over.
Sir, what is the extra question?
Extra question was that to find the HCF and LCM of 160 and 320. Dilshanur Rahman, let me be sure that you are attending the session physically. Dilshanur Rahman, if my sound is going to you, turn the video on. Yes. What's about the answer? Okay, till now you're solving, but time is already over. So you write some question, everyone. Find the HCF and LCM of
Sir,
the
homework.
following number. Extra question, everyone. It's a very important topic you are having multiple times in the syllabus. You will get the same thing in the class 10 as well. So write the question, extra question, find the HCF and LCM of the following using prime factorization method. Just you repeat the question number 6. And number 1 you write. Number 1, to find the HCF of 180 and 460. Number 1, we have to find, or you have to find the HCF and LCM of 180 and 460, and that's using prime factorization method. Number 2, 220 and 630. Number 3, 250 and 550. And number 4, 178 and 280. That's the 4th question you have to solve, or you have to find the HCF and LCM, and that's using prime factorization method. And after solving, you have to capture the photos, and after taking it, you have to convert it into PDF form, and with your name and rule you have to send in my WhatsApp. And my WhatsApp I am sharing with the people. Actually Sari is not allowing to share the screen. My WhatsApp number already you know. You can take it from Abul Hassan. 9365 418512. By today itself we have to give the task. Okay, your time is already over.
So 9365.
That was all about the today's session, where we discussed the question number 2 to 6 of the exercise R1, where the major thing was to find the HCF and LCM and to solve some questions regarding rational number and irrational number. Okay, thank you everyone for joining the session. Hope you understood. If you are having till now any question, any doubt, any queries, you can send the resume in the WhatsApp. I'll try my best to answer it. Yes, assalamu alaikum warahmatullahi wabarakatuh. You can leave now.